right, thank you everybody for joining us. This is our third workshop in the Saving Our Streambanks virtual workshop series. I just wanted to welcome everybody. We're excited to have Chuck Davis with Beaver Creek Hydrology here with us today. And before I let him kind of take over the presentation, I just wanted to go through some quick things. A lot of you have seen this, but for anybody that's new, I just wanted a chance to show you the whole workshop schedule. My name is Lindsay Nicholas. I'm with Bluegrass Green Source. I'm the watershed coordinator for several focus watersheds in our service area. And we have our water quality and streamside buffer 101 workshop repeated again this Thursday at 3. So that's the same workshop that we did on Tuesday, last Tuesday. For those that were not able to attend, we're offering that again since it is a required one for our riparian mini grants that we offer. So just a note on that. And we do have 2 more workshops next week that we're really excited about: the ag conservation panel discussion and the streamside plant selection in Central Kentucky discussion with Ironweed Nursery and Open Farm Trees. So that's what's coming up next week. With that, just a couple reminders. The Zoom link is the same for each workshop. So just use that same link to join us every Tuesday and Thursday at 3 for the next 2 weeks. Your virtual packets are all available. I've pasted the link to that in the chat, so that should be available, and it's been sent out in email, but let me know if you have any questions. Just as a reminder, please keep your microphone muted during the presentation just to keep the background noise down. If you do have questions while he's presenting, feel free to throw that in chat, and I'll monitor the chat just in case we need to ask something during his presentation. He's totally fine with that. So we can do that, or we can just wait for questions at the end if that's a little bit more appropriate. And you can also unmute your microphone to ask questions at the end as well. So feel free to just continue the conversation in chat, and we'll have time at the end for questions. For anybody new to Zoom, I go through this every time, so I'll go a bit quicker this time, but the mute's right there in your bottom left corner. If you want to change your name in participants or see who's on, you can click on participants and go to more and rename yourself so I know who's here. In the chat feature should be right there in the bottom, and you can go to reactions and raise your hand or give reactions right there with that smiley face. On your phone, it looks very similar, but your unmute's in that bottom left corner. Participants in that 3-dotted line more section, it'll bring up this pop-up where you can then find the chat feature to ask questions. So again, my name is Lindsay Nicholas. These are the links for the virtual packet and the workshop series website, but I am going to stop presenting and turn it over to Chuck.
Thank you, Lindsay. All right. Thank you so much. I'm going to start sharing my screen, and I've got a presentation to share with the group today. First of all, thank you to Bluegrass Green Source and Lindsay for having us. As she mentioned, my name is Chuck Davis. I'm a professional engineer licensed in civil engineering in the state of Kentucky. We listed 2 presenters today: Derek Scott, my colleague at Beaver Creek Hydrology. He was unable to join me today. I'll be giving the presentation, but he and Melanie Mossing and my company were instrumental in putting this presentation together. So I would first like to thank them. We've titled the presentation today, Streambank Stabilization and Stream Restoration, Design, Permitting, and Construction Considerations. So the talk title initially was Streambank Stabilization, and my company focuses in one thing. We're a civil engineering professional consulting firm that focuses in stream restoration. So that's a big topic. It's an umbrella topic that includes a lot of material. One of many things that coined stream restoration are stream bank stabilization practices and ways to help save land or help to stabilize a stream bank when you've got problems that you're being faced with due to stream bank erosion. So that's the reason for the double title. Stream bank stabilization I consider a subcategory of stream restoration, and I'll be talking mostly about stream restoration at the large scale today and focusing a little bit on stream bank stabilization for a portion of the presentation. A quick overview of my presentation. I give these talks quite a bit. My company, again, we focus solely in stream and wetland restoration for lots of different purposes, primarily for compensatory mitigation, which is a federal rule that requires somebody who wants to develop or fill in our streams and our wetlands. It requires them to offset the loss of that aquatic resource by restoring or reestablishing another aquatic resource somewhere else. So if the Kentucky Transportation Cabinet comes in and fills in a stream via a culvert, and they want to culvert or pipe a stream for some distance under a road, the federal rules under the Clean Water Act from 1972 require that they go and offset that loss of stream habitat for our various aquatic organisms by restoring a stream somewhere else of a similar length to that culverted length. So that's the world that I work in quite a bit, stream restoration for large development projects. And with that in mind, this presentation will probably bend towards a highly technical bent. Those are the types of presentations I give a lot, and that's what I work in every day. So I've tried to be aware of that and bring that down to a level that's attainable for a broad audience. People that I know on the call here today, people may be looking at doing something on a small creek in their backyard. So I'll try to not make this overly technical for large scale projects, which is what I work in a lot, but I'll try to make it accessible for smaller scale projects as well. But with that, I'll give an overview of what I'm going to talk about, and hopefully that'll help to couch some highly technical slide that I'm trying to run through quickly within the context of the larger presentation. I'll give a quick background of my company and myself. I'll talk about when we need to restore a stream, what a stream restoration project means, what it is, what the need for it is, and what goals of those types of projects are. We'll talk about the permitting process, if a permit is needed for a stream restoration project that you're trying to complete, what that process looks like, how long it takes, the steps involved in obtaining a local, state, or federal permit or federal permit to complete a stream restoration project. We'll talk about what you can do yourself. We'll talk about that specific to stream restoration and what you can do yourself without a permit and what you can do yourself within the context of a permit, or what you can have someone else come in and help you do. One of the biggest things we'll talk about today as far as what you can do yourself is stewardship and riparian management. I'll talk quickly, assuming you need a permit, I'll talk about the stream restoration analysis, physical processes that dictate how we do stream restoration, such as stream evolution. I'll talk about the construction phase of the project after you get the permit with the full design and the permit complete. How do you go about constructing one of these large scale projects? And then I'll talk quickly about failed restoration projects and successful restoration projects. I want to talk about that to couch how your goals for what you want to try to accomplish tie into what you achieve at the end of your project. Beaver Creek Hydrology, again, as I said, is a professional consulting services firm. I'm a professional engineer. We operate primarily as an engineering consulting firm, but we also have a biologist and ecologist and other scientists on staff to do a full suite of environmental services under the banner of professional consulting. We were started in 2006, and we focus solely on stream and wetland restoration. We complete design, permitting, and construction management services for stream restoration and wetland restoration projects in the region, in the Ohio Valley region primarily, Kentucky, Ohio, Tennessee, Indiana, but then we work a little farther afield as well, all over the US. We've completed the design, permitting, and construction oversight of close to 200 miles of streams. As a company, we're very proud of that number. We've done a lot of this work. We're very well suited to provide design, permitting, and construction oversight services. We're not a contractor, just to be clear. Some companies like ours will do the design, and we own equipment, and we'll have operators that can come to your property and do the work that we design as well. Beaver Creek Hydrology is not a contractor. We are just an engineering consulting company. And as I said, we provide primarily stream restoration services and aquatic resource mitigation. We also, as part of that, provide hydraulic modeling, construction management, and monitoring or success monitoring for these projects. Why do we need stream restoration projects? What are considered impacts? If I put impacts in quotes here because that goes back to the Clean Water Act. What an impact to a stream is in our world is defined legally as something that will affect a jurisdictional waterway under the jurisdiction of the U.S. Army Corps of Engineers. So what can be considered an impact? Bank erosion and land loss is a negative impact. I want to point out as well that not all impacts are necessarily negative. A lot of them will negatively impact our habitat for aquatic organisms, but not all of them. And some impacts are necessary. They're societal and economic and scientific parts of every project that we have to balance. Obviously, flood control in urban areas is very important, and hydropower production is a very important impact, but it is an impact, meaning we alter our nation's waterways, our streams or our wetlands in some way to achieve an engineering end. So some negative impacts include bank erosion and land loss, piping and filling. We need them for roads and things, but we do lose those water resources. We lose most of the function of the water resources in those scenarios. Channel straightening has happened over the course of time all across Kentucky. I've seen it all over Kentucky, where you try to straighten a channel to improve flood conveyance or to drain a field or to do a number of things. That's a common impact to streams as considered by the federal government. Unfettered cattle access to streams, while can be done in a way that's sustainable, can also have water quality impacts that can be considered an impact to stream. So these aren't only just physical impacts, but also impacts to chemical and biological elements of the stream, water quality issues. This is not an exhaustive list. These are some of the types of impacts that can require restoration. Specifically under a management scenario, I'm assuming that those on the call today either have a problem they're going to try to address via a grant with Lindsay or via some type of larger conservation grant program regarding a management issue, or just trying to make some improvements. And we want to talk about those specific types of impacts today and how we can manage the streams in the best way, how we can optimize our management of streams for biological uplift and for economic reasons and for cultural societal reasons. That's our goal of Beaver Creek Hydrology, is to optimize these water resources systems. Here you can see a few, I'm going to have to play with my Zoom a little bit. Here you can see a few different representations of impacts. This is an obviously straightened channel that has been concreted for flood control conveyance. This improves flood control conveyance by removing natural substrate and things like that to this waterway. That's what we would call a traditional civil engineering solution to flood conveyance. We see here a slumping gabion basket below a road. This gabion basket was installed to protect this road embankment, and it over time, via erosion at the toe of that gabion basket, has started slumping into the stream. Here we see just a large, tall, this is probably an 8 to 10 foot tall eroding bank of a stream where a meander is trying to move out into a field and take land away via erosion processes. So these are some of the things you can visualize as impacts to streams. So based on what the impacts are, what are our goals of stream restoration projects? The goal I work within, mostly the context in which I work in my job, is to design stable alluvial channels. Stability is an interesting word to use. It's vague, and we use it a lot in the federal guidance on our permit development, but it's a term that we need to define nonetheless, because that is the goal that we're trying to accomplish with a lot of these restoration projects. A stable channel is defined as a channel which transports its supply of water and sediment without an objectionable net change from erosion or deposition over a basic hydrologic cycle. What we're saying there is we're going to build a channel that remains in place after we finish the project, and it will function to optimize all of those uses I just talked about, be they biological habitat uplift uses, be they land management uses to reduce erosion or loss of land, things like that. So the goals can vary by project and can be numerous, but a stable channel is often my goal to provide a lot of these various types of goals you might have for a stream restoration project. Like I said, habitat improvement, stability or erosion reduction, infrastructure protection. For example, in the last slide, that roadway that was being eroded away, we needed to protect that infrastructure, and we can do that via stream restoration. Downstream flood reduction, recreation purposes even can be a goal of stream restoration design. I'm going to assume in this group that it's mostly stability and erosion reduction or land management uses, but I just want to point out that the goals of stream restoration projects can be numerous. Where are we? This slide is important given the permitting question. So if you're going out and you're trying to address a problem you perceive in a stream on a piece of property that you own, or you're part of a group that's trying to address an issue, for example, a municipality where there's a stream coming through your city that's causing erosion problems in an area or threatening a sewer pipe or something. Where are we? And by this, I don't mean where are we in the world. I mean, where are we relative to the stream? So we need to know the definition of an ordinary high water mark. That is a legally defined term that is typically identified as the change in vegetation community near a stream. It can be defined a lot of different ways. The way I like to define it primarily is the level below which your common flooding occurs and the point at which you would consider the water spilling out from the channel, what's considered the normal channel or the ordinary channel, and spilling out into a floodplain, or just rising above the level of the normal channel and causing problems. So if you're in a gully, a deep entrenched gully, the normal level is well below the top of bank. It's well below the top of the gully. But I would consider the ordinary channel, the channel above which problems begin to occur. So in a deep gully, if the gully fills up in a large flood event and you start to see erosion of those vertical gully banks, that's a problem. So the amount of flooding that's contained in the gully is above the ordinary channel at that point because it's causing problems. So that is an important channel to be able to define when you're trying to determine whether or not you need a permit. And that's the reason I want to talk about it today. If you're working inside of the ordinary high water mark, if you're working inside of the ordinary channel, you almost invariably will need a permit or will need to consult with someone for a permit, unless you're just doing planting. If you're just doing planting within the ordinary channel, you may be able to get away without doing any permitting at all. But if you're doing earthwork with a shovel or with a large piece of equipment and you're entering into the ordinary channel, then at that point you are within the ordinary high water mark and will likely need to consider a permit or talk to someone who has knowledge of permitting issues to determine if you do or don't need a permit. If you're above or outside of that ordinary high water mark and outside of the ordinary channel, you oftentimes will not need a permit, but it still can be good to consult with a permitting expert just in case. Bank stabilization of a vertical bank. So if you have a deep gully and the bank is vertical and it's 8 feet deep, for example, obviously, if you do work at the top of that embankment, it will likely cause impacts to the ordinary channel. Therefore, you would need to consult a permitting expert to talk about your need for a permit potentially, because the work that you're doing in the near bank area would impact the ordinary high water mark or the ordinary channel. So that's an important thing to know when you're getting into this type of work, is whether or not the earthwork you may be doing for your stream bank stabilization, if any, will impact your ordinary channel. Activities outside the ordinary high water mark that are common include riparian zone management, riparian zone exclusion, which means like buffer management or fencing of cattle, things like that, and then planting would all fall under this category, which I refer to oftentimes as stewardship. Stewardship is the umbrella category I use for land stewardship in your riparian zones, basically. Activities inside the ordinary high water mark include bank grading. Again, bank grading is often considered to be inside the channel because likely your grading work, even if you think you're outside the channel, it will likely affect the channel, especially in a case where you have very steep vertical banks on your stream. So bank grading is often considered an activity within the ordinary high water mark. Channel realignment or full-blown stream restoration. When I'm using that term here, I mean a complete manipulation of the channel shape and form and size. That type of stream restoration would definitely be within your ordinary high water mark channel, and it would require a permit, more than likely. So resources for you. This document here, the Central Kentucky Backyard Stream Guide, was put together by the UK College of Agriculture, Food and Environment, and it's part of the Cooperative Extension Service. It's a great resource. You can get this online. I can provide links to Lindsay to distribute to the group, everyone that signed up for the webinar, and in the chat here in a few minutes. This document is a brief layman's guide to a lot of the stuff I'm going to talk about today. When do you need a permit? How do you figure out the problems you're experiencing with your stream? How to address those? Do I need to address them with passive activities where I just try to avoid the stream? I try to move my area of mowing further back and create a no-mow zone, and hopefully that will help with my problems I'm experiencing with my stream. Or do I need more of an active approach where I do plant management in the immediate stream corridor or in the near stream region? Again, that may or may not require a permit. Or do my problems constitute the need to actually go into the channel and move the boulders and the substrate that make up my channel around and do a full-blown stream restoration project? This is a good guide. It's brief, and it will go through a lot of the same stuff I go through today I'll just give more detailed, fleshed out examples of what I do in my job every day to show you some examples of what stream restoration is. But as far as the process of how to determine what you should do, how to start thinking about that plan, this is a really great guide. So the local UK Extension office, which is shown here at the bottom, is a great place to start to talk to people. Your local county soil and water conservation district is a good place. Resources like this online are good. And then if you're thinking, okay, I really think I may be in a situation where I need to obtain a permit to do the work that I want to do, here are some additional contacts where you can reach out to the Division of Water, the Kentucky Division of Water, which is the permitting body in Kentucky, or the U.S. Army Corps of Engineers, the permitting body for the federal 404 permits. There are a couple of telephone numbers here that you can call and try to talk to someone. Beth Harrod, who runs the water quality section at the Division of Water, is a wonderful lady, a state employee who really always goes out of her way to help people, and she's a good person to talk to. If when you walk through my presentation today or some type of resource like this, the Stream Guide, and you think you need a permit, Beth is a great person to call to talk through issues related to permitting things. In addition, I would encourage everybody on the call today to feel free to reach out to me. I'd love to talk to people about projects they're thinking about involving stream restoration on their property. So stewardship, going back to those outside of the ordinary high water mark, outside of the ordinary channel activities that you can do. This is a big part of this presentation. And normally I would spend more time than I'm going to today on this topic because it's so important, which is riparian buffer management and planting of native plants. However, this has been put together really well, this webinar series. Lindsay's put together just a great slate of speakers. So I'm going to try as much as I can to leave the discussion of native grasses and plants to the experts from Ironweed and Roundstone and others that are going to be presenting in this webinar series. Rob's presentation from Roundstone was awesome in regards to native plantings for grasses in the riparian corridor. And he said it better than I could anyway. So I'll try to leave the planting conversation to those experts. As an engineer who specializes in stream restoration, I utilize planting native herbaceous and woody species in all of my projects. I would consider it at least 50% of the overall project plan that I put together for my large scale stream restoration projects. 50% of it hinges on the successful establishment of native herbaceous and woody species for plants to establish and really help that riparian corridor thrive. I'm going to show a lot of pictures of construction. It'll look like I focus almost 100% on construction, but in reality, the construction part of stream restoration is just setting it up, is just creating a successional pathway within my riparian corridor where my riparian native plants can come in and really thrive and do the rest of the work to complete the stream restoration project. So that's a big part of what we talk about when we talk about stewardship of riparian buffers, is planting native grasses. As Rob talked about, it's really important that you understand the invasive species you have within your riparian corridors and remove those if necessary, and any soil preparation as needed. And then just make sure you have a good plan to get those native plants established as part of your stream restoration project. Other things that I talk about a lot under the umbrella of stream restoration include other riparian corridor stewardship activities, including fencing out cattle. This is an example here. This picture is an example of a hardened single point water access for cattle in a stream, as opposed to allowing unfettered access up and down the stream. If you can create a hardened rock ford type crossing that allows cattle to access water in a location, you can reduce some of the stream bank erosion problems and riparian corridor plant reduction that happens with grazing, that then further destabilizes your stream banks and allows more erosion to happen if you can control your water practices with your cattle by hardening a single access point for those cattle. Reducing mowing and having no mow zones is great. Conservation farming practices can be helpful for stream bank stabilization as more of a riparian corridor and stewardship practice. And then bioswales through farms can help as well. So the next part of this presentation, we'll talk about permitting, design, and construction of stream restoration projects that I practice typically in my job. That has already assumed that you're primarily working with an activity that will require permitting, and you're not only doing something outside of the ordinary high water mark in your channel or outside of the ordinary channel. such as passive management or planting, that wouldn't require a permit. So you've gone through the process basically at this point of determining, can I do a passive approach or a minimally active approach of planting, which is still important, but I use the term minimal, meaning as compared to the construction you'll see in the next few slides, which is very invasive. So you're either doing a passive management approach or a minimally active involving planting in your riparian corridor. You've determined that those aren't feasible. You've ruled that out for whatever reason, and you need to go down the permitting path to design and construct a more significant project that will definitely affect your ordinary channel within your ordinary high water mark. So we've reached that point now, and the rest of this presentation will assume that we're already down that road. The stream guide that I showed a few slides ago, again, is a helpful tool to help you think through, do you need to do that or not? And I'd be happy to, as a resource, to talk to any of you all about that as well. Beth Harrod at the state would be happy to talk to you whether or not you end up needing a permit. She's a good resource as well to talk about whether or not you arrive at this point. But assuming, under the assumption that you arrive at this point, you need the permit, you need to move forward with a more significant structural type fix for your stream bank erosion issue. The rest of this presentation will be based on that assumption. So the permitting process, you have multiple agencies you may end up working with, including the U.S. Army Corps of Engineers for the federal 404 permit, the Division of Water for the state water quality permit, also referred to as a 401 permit, or any local permits you may need from your local county or municipality. Typically, these permitting conversations can be complicated, and they're very much case-by-case specific, but we typically find that we used to use linear feet. The Corps and the state used to use linear feet. Now they've changed that more to square feet. So, or acres, you can think about it in acreage. Now the federal rule says that if you are going to fill in more than 3/100ths, in other words, that's 3 square feet out of every 100 square feet of that stream. If you're going to fill in more than 3/100ths of an acre of stream or 1/10 of an acre of wetland, you will almost invariably require a permit. If you're less than that, you may or may not require a permit, but you could still talk to the U.S. Army Corps or the Division of Water about what you may need to do to get approval for the project. But that's a specific number. It's a small number. Another way to think about 3/100ths of an acre, it's about 500 feet of a 3-foot wide creek. So if you're doing a project on less than 500 feet along a creek, if the creek is 3 feet wide, if it's a very small creek on your property, then you can more than likely move forward without a permit. But if your creek is 20 feet wide, or 30, if it's 30 feet wide, you can only do 50 feet along that creek. So that that area, thinking about it as far as area goes, as opposed to linear feet, just helps you understand the amount of stream and the size of stream and wetland you're going to fill in before you need a permit. Again, if in doubt, call Division of Water or call a permitting expert like myself. As part of the permitting process, you will consider up and downstream impacts. And there's the Fish and Wildlife Philo Stream Team. For those of you that are going to be in a situation where you need a permit and you're more than these limits, but you're having problems coming up with funding, they're a funding source, and they're also excellent and experts at these permitting questions. They would be able to help you as well. They're another good resource in the permitting process. As we just talked about, the types of permits you may need include the Army Corps of Engineers 404 permit, the Division of Water 401 water quality permit. You may or may not need a Division of Water stream construction permit, floodplain permit if you're in a regulated floodplain. For those of you all that have bought a home in a regulated floodplain, you know that's the mapping that is required to be checked when you obtain a mortgage on a private residential property. If you're within the floodplain, they require that you obtain flood insurance along with your mortgage, and that's the same floodplain. If you're in the floodplain for these types of stream restoration or stream bank stabilization projects, you may need to consider, you may be required to obtain a floodplain permit as well. Anytime you're working on large scale construction, including in streams, you may need a construction stormwater permit. Those may be required when you're working outside of streams as well for anybody that's done development of larger tracts. And then local construction or water quality permits. In Lexington, some of the topics we'll talk about today, even potentially planting riparian corridors depending on where you're planting, may require a local LFUCG permit from the Fayette County government here in Lexington. So you need to be aware of the local permitting requirements as well. Some counties have far less stringent local construction permit requirements, but then some have higher and more stringent construction permits. All right. The next few slides are some of the technical slides I was talking about earlier in my presentation. And I'll probably go through these relatively quickly, but if you have specific questions about anything you see on these slides, I'd love to talk about with you offline or at the end of the presentation today. But this is the meat of the engineering analysis of what I do for stream restoration. So to obtain a permit, you have to show your plan. You have to show the design of what you want to do to stabilize your stream bank or to restore your stream. To come up with that design, you need to do some type of analysis. You need to do data collection and determine the steps you're going to take via construction with heavy equipment or via construction using hand tools or anything else. You'll need to do the analysis to show in the permit the plan you're going to implement. Data we might collect include cross-sectional information of the stream. So how wide is the stream? How deep is the stream? What is the bed material? That's what a pebble count analysis is. Is the bed sandy material or is it all boulders and cobbles? Things like that. We can do other survey measurements for cross sections and longitudinal profiles, and then all types of analysis for how likely is my bank to continue to erode. A bank erosion hazard index is one type of analysis you can do to determine the likelihood of your bank to continue eroding in the future. And those are the types of physical data we can collect. We can collect habitat data to help figure out what types of fish and macroinvertebrates or little bugs are living in our creeks. We can look at the native and invasive species analysis for our near stream herbaceous and woody plant species. Even some of our in-stream plant species that live in the water. And then finally, in the engineering world, we do modeling and design. The natural channel design methodology is what we use at Beaver Creek Hydrology to design stream restoration projects. And then we can do other numerical modeling, which are models that help us to estimate the velocities and the shear stresses and the erosive force of these flows that come down these channels based on their physical characteristics and some of their biological characteristics as well. This slide just shows a few different types of cross sections you might see. It's intended to show the difference in, for example, a deep channel that we call a gully. It's often deep and over widened compared to that ordinary flow or that ordinary flood that defines our ordinary channel or that defines our ordinary high water mark. We've all seen gullies where the channel bed is 10 feet deep and the stream banks are 10 feet tall, but you're still in a small creek and it seems like the channel is much larger than it should be. Well, that's likely due to some type of geomorphological instability in the watershed, meaning that maybe somebody dredged that, or maybe upstream they built a lot more impervious area like parking lots, or there was some other type of development that caused water to not infiltrate into your wetland and riparian areas as well, but to get into the creeks more quickly and then to rush down the creek and have a significantly increased amount of erosion compared to a non-developed watershed, for example. This happens oftentimes in urban areas. Once you pave so much of the acreage of a watershed with asphalt or concrete or hard roofs or buildings, things like that, the water gets into your creeks a lot faster than it used to, and it will increase the rates of erosion compared to natural historic rates and create gullies. This is compared to a cross-section that, for example, may have a small channel that quickly gets onto a floodplain and then floods a large area. That would be biologically, generally that's considered a more healthy functioning riparian corridor because the water that sits out in the floodplain during the flood event will be able to process more of the nutrients. It will be able to drop sediment and not create the erosion problems that you see in a gullied system that has been negatively impacted by development upstream. These are just a few of the types of cross sections you might see in the system that you're trying to work in. And all of those things definitely affect significantly the way you would go about implementing a stream restoration design for permitting purposes. This is a stream evolution model. This just shows a lot of different types of channel cross sections and how they develop over time as a response to different types of erosion processes. Contributing factors to these watershed scale processes include climate, hydrology, hydraulics, and sediment transport. These are all things that I've studied, and they're very detailed and required for some large permits or large projects that require permits. They're not always required, but once you get into trying to work with large sections of rivers or creeks, you can see very quickly that the science behind it becomes very complicated. It's difficult to control a stream bank with one slam dunk method that will always work. I will not be presenting today one type of system or one type of method that always works for stream bank stabilization, because every river varies in the way the problem is presenting itself. And it's good to talk to a permitting expert and an engineering expert when embarking on a large scale stream restoration project to understand all those processes that are going to affect your stream or river. Then once we collect all of our data, we incorporate that data into our stream restoration design. We utilize a natural channel design approach, which uses a combination of structures using boulders that will lock the stream in place for stability, as well as optimization for biological and other land management considerations. We use the term natural channel design to differentiate between, for example, that channel we saw earlier that has just a long, straight concrete chute. We wouldn't consider that natural, because in those designs, in our opinion, don't prioritize or focus on the biological aspects of that stream and the biological functions it could serve. So we want to balance the goals that channel was trying to achieve with the concrete channel of flood control. We want to incorporate flood control in our designs, but also include the biological uplift and considerations of biology and biological function. And that's what we mean with natural channel design. We will, for any creek we're working in, we're going to develop data and engineering information for our design very specific to that area, not just from your creek, but also from creeks in that area. If your farm drains into the Licking River Basin or into the Kentucky River or into the Dix River or others, we've got data in our internal database specific to that watershed to help us really refine our design to match all of the climatological and physiological processes going on in your specific watershed to give it the best chance of success in the natural channel design approach. And then finally, we've developed and coded some of our own internal software tools. This Bankful mathematical model is a computer code that I've worked on that helps us design channels and build them on the ground. I won't bore anybody with the specifics of that, but it is something we're very proud of internally in regards to our engineering approach to these designs. So again, one more time to talk about the cross section. This is a screenshot from that Stream Guide handbook that I showed earlier that the UK Extension Office put together. As part of your planning for what you want to do on your property for a problem area or for a stream, this is a really helpful first step. You can try to sketch out a rough cross section. You can try to measure the width of your stream, the depth. You can try to represent the type of material that's in the bed of that stream. And then the area that floods very irregularly, the low area that floods often when you are just out of banks, when you get just outside of your ordinary channel or just above your ordinary high water mark. You can sketch how wide is that area and how high above the low flow water surface does that sit mostly. And then the next level up, maybe a house or a barn sits up here. You can try to sketch these cross sections. That will definitely help when you're trying to put together a plan for stream restoration. Even if your plan is only to plant, if it's not to do any work in the channel and you don't need a permit, for example, sketching out this cross section can help you to visualize where you want to plant certain species. These low-lying areas near the stream will be wet much more frequently than these higher areas. So when Roundstone or when Ironweed talks about trees and grasses that are well adjusted to very wet areas, you would look at your cross section across your stream. This is kind of perpendicular to the flow of the stream. You would look at this cross section and say, I could plant the wetter species down here in the bottoms, and then maybe drier grasses or drier trees that don't do as well in very wet areas, a little higher, a little further away from my channel. So the cross section, which is what I would be data that I would collect for my analysis for restoration design, is a good place to start for your conceptualization of a stream restoration project on your property as well. So now, assuming you're in the permitting world, and now the rest of this presentation primarily assumes that we're doing a large scale stream restoration, again, which is the world I work in, and I want to talk to you all about a little bit today. We would move then from all of that detailed data collection into a set of construction drawings. We would do all of our analysis based on our engineering, mathematical modeling, things like that. And we would develop a typical civil engineering site grading plan to help us implement our stream restoration project. What we see here, which I know is a lot of colors to look at on the screen, but this meandering curvy pattern in the middle of the channel, in the middle of the page, excuse me, is my designed channel. It's my natural channel that we've designed to improve the habitat of this system and to reduce erosion. This dark black line, which you see here, is was the existing stream on this property prior to restoration. It had been moved over to one side of the valley by a long history of farming and silviculture practices, logging practices on this property. It had been moved over to make more arable land, but what that had done over time is that channel had eroded. It was about 12 feet deep at this point, and that bank erosion was causing a lot of instability. So what we did is we came in and we filled in the old channel and built a new channel much higher in elevation that was much less deep. It was much less like a gully, a small channel that connected more quickly to its floodplain. So we turn our design into a set of construction plans that can then be built on the site the site of the stream restoration that you're trying to implement. Here we see that we use heavy equipment and lots of native materials. By native, I mean if we're in an area of Kentucky that has native limestone bedrock, we try to use limestone boulders and cobble and gravels to build the bed of our stream back that would mimic or reflect a natural stream bed that's observed, that's less impacted somewhere else. And we utilize heavy equipment to implement this large civil engineering grading plan and the materials we use to rebuild the channel habitat. Common stream restoration structures that are utilized in the channel to meet both goals of stability and reduction of erosion, as well as habitat improvement, include boulder cross veins, boulder J-hook veins, tow wood structures, which are shown here, and I'll show more pictures of those later, and boulder clusters. That's another differentiation between what we refer to as natural channel design versus more of a traditional civil engineering approach, which is we try to use materials that would have existed in a stream prior to anybody creating any impact or disturbing that stream in any way. Boulders function to provide the stability that concrete can provide in certain systems, but it has the added benefit of all the void space in between the boulders, which we fill with cobbles, and we fill the void space in between cobbles with gravels on down. All of that interstitial void space creates lots of good habitat for macroinvertebrates, for fish, things like that. So by using native materials and boulders reminiscent of what are found in channels that are undisturbed, we can build them in a way and we can create hydraulic structures that provide stability, but also that still provide a lot of biological benefit as well. Cross veins are grade control structures. By grade control, we mean they prevent head cuts from moving up and down channels. Head cuts are just defined as large, vertical, abrupt, uncontrolled drops in the stream bed that are due to erosion. So if anybody owns a farm near a large river that drains from a field directly into the Licking or directly into the Kentucky, this can happen often, where over time, a portion of your field next to the river can begin to erode away from the river. And that process is called a head cut. The drainage from your field will slowly erode back the stream bank from the larger river. It doesn't have to be as large as the Kentucky River either, but these head cuts can form in many different size streams, and a boulder structure can provide grade control to prevent that vertical head cut from propagating further upstream and into your property. So they provide stability in the vertical dimension. They function very nicely for bridge pier scour countermeasures. They're utilized often in urban settings even, or in settings around infrastructure to help protect infrastructure by stabilizing the stream and reducing erosion. Here's an example of a large boulder cross main structure that was engineered and built to help protect this bridge. The abutments had been eroding over time, and the cross vein structure is designed as a weir. It acts as a weir to help direct flow away from the eroding stream banks into the middle of the channel. It maintains a deep scour pool, which helps further to direct flow towards the middle of the channel, and it can be used to help protect bridge abutments and other critical infrastructure. This was a restoration project with a large cross vein that was constructed. And as you can see in these pictures, they look natural. While they're a highly engineered structure, they still look and function in a natural way in the river. But this structure was built in this bend to help reduce erosion along the outer bend here. Boulder towwood structures are another type of structure that are often used in stream restoration to help with stream bank stabilization and other stream restoration goals. This is a large building. This is actually a church in a municipal area. This stream was eroding the left bank over time. The stream is moving downstream in this picture, looking away from us. And over time, the erosion along this bank was worsening. The only construction had already started at the time we took this picture, but the only difference here in the pre-construction condition and this condition during construction was this bank was covered in bush honeysuckle. And for those that aren't aware, bush honeysuckle isn't a very deep rooting plant. So it doesn't provide a lot of good deep soil stabilization. So we had removed the bush honeysuckle. That was part of our permit plan. And we began to build this towwood structure. By stabilizing the toe of the channel here with engineered materials like core mat and live materials. These trees here you see are actually live stakes that will begin to grow. By stabilizing the toe of this embankment, we were working within the terms of our permit to prevent the additional migration of this bank away from us in this picture towards the building. The building owners obviously were nervous about this continuing to migrate and causing problems with their parking lot and with some of their water pipes, things like that. So we wanted to stabilize this bank. We excavated down, we placed in the toe of the bank engineered materials and live materials. These again are live stakes. And then 2 years after that picture was taken, we're now looking in the opposite direction. We're looking upstream, but we see that those live stakes had grown. Trees, willows, other very wet rooting tree, woody species were used as these these live stakes, excuse me. And over time, they began to sprout new vertical shoots. So over time, that toe of that bank will be replaced basically with a living root mass, and it will provide all the stability of the bank that we needed to prevent continued lateral migration towards the building. Again, we laid the bank back a little bit further as well to allow by reducing the slope on that bank with heavy equipment. We were able to enforce or encourage our plant establishment, our herbaceous plant establishment along this bank with a lesser slope. And that was part of the project. I'm standing on a cross vein taking this picture as well. So these structures can be used together, a cross vein with a towwood structure to help us to protect infrastructure, things like that. These boulder clusters are neat features. They are used primarily in the middle of the channel for habitat. This is another example of a type of stream restoration project that functioned a goal of recreation. We were helping to improve a whitewater corridor here. This is actually in Colorado, Clear Creek, Colorado. So boulder clusters are another habitat type structure that are often used in natural channel design. These don't affect stream banks as much, but it's just a different look at what you can do with stream restoration practices. Really quickly, this is a lot of, I'm not going to go through this table. I'm just going to point out that in my experience as a design engineer, use a lot of cross veins, J-hook veins, boulder clusters, towwoods. But if you go to 10 of these presentations about stream bank stabilization, you'll hear 20 different types of structures you can use. I want to point out that one of the best structures you can use for stream bank stabilization, or the best approaches you can use, which is in everybody's list always, are seeding of the stream bank with herbaceous and then live stakes or other native woody species of plants. Planting is an integral part of streambank stabilization, and I recommend it very highly for anybody looking to do work on their own without getting a permit. If you do require a permit, I would recommend highly that you talk to a permitting expert or an engineer to help you understand what needs to be done for your project. But if you don't require a permit, the best thing you can do for streambank stabilization on your property is the installation of native plants via seeding or live staking. So that will be on everybody's list. There are many other types of structures, and they're all different kinds of variations really on cross veins or toe woods if you're working in the channel. But those aren't the only types of structures. We use others as well. Additionally, when you're doing in-stream work, you're often working in the floodplain as well. So it's important to know how the channel interacts with the floodplain. You can't just build these structures in the creek and not understand how it will interact with the floodplain. You have to know and understand your final floodplain grading as well. So that's an important part of the project outside of the channel. Once you've moved dirt and you've unconsolidated your soil, erosion control is very important. The main reason I say that 50% of our projects for natural channel design are planting related is because immediately after construction, we have a lot of soil that can erode if we have a flood before plants establish. So seeding of native herbaceous species is really important. Rob's graphic from the presentation last Tuesday or Thursday was really cool, how deeply all those native grasses root, which is why we use native grasses as well. They're extremely deep rooting plants, as opposed to fescue, which he showed in that same graphic, being very shallow rooting. So we like to use native species for the biological benefit, but also they have the added benefit of really locking in your providing deep rooting and significant erosion control on a recently disturbed site. Other types of engineering materials we use for erosion control, these are all biodegradable, by the way, our core fiber matting and certain silt fences are now biodegradable. We spec all biodegradable materials on our projects, and all core fiber matting is usually either hemp based or coconut fiber based, which is also biodegradable. Here you see in this figure a lot of core fiber matting used to provide erosion control on a recently disturbed stream restoration site. I'm about out of time, but I do want to say quickly here that failed restoration projects and risk to successful restoration are critical to understand. If you go out and just try to build one of the structures that I showed today to protect your bank that's eroding towards your barn, for example, and you don't size it quite right, or you don't have the elevation of the crossvein tie into your floodplain elevation quite right, what you'll see is they may not function as you expect them to. In this case, in several of these cases, structures were attempted to be built that weren't sized quite correctly, and they didn't really do much. The bank erosion continued. They didn't function as they were intended because all of the engineering analysis that goes into how to build these wasn't completed properly, in my opinion. So it's important to know that setting your goals are very important to know what you want to do. But then if you require a permit, really understanding the processes that are associated with streams and how to prevent that erosion is important as well. These are some pictures of our projects where structures are functioning over the course of years as they are intended to, and we're proud of these. So they can be great projects when they are successful, but successful projects require a lot of detailed analysis and expertise in this area of stream restoration. And then my last few slides were just some slides regarding one project that we thought was just a great success that we finished 2 years ago now in 2019. It's called the North Branch Sycamore Creek Project. I showed a picture of it earlier. This was a gabion basket that was intended to stabilize this road embankment. The road is above the gabion basket here. And the stream, I'm standing in the stream, it flows directly at the gabion basket and then makes a hard right-hand turn and flows to the right down this wall along the road. So what was happening is erosion was significantly affecting this critical infrastructure. This is a picture of our project that we designed with a J-hook vein here, deeper pools. The channel was realigned to improve the shape of the flow towards the downstream reach as opposed to flowing directly into the wall and then turning right and going downstream. And we used a tow wood here. The tow wood structure is going to provide that long-term living mat of material, of root mass that will stabilize this structure. We use that actually in this case in concert with some riprap as well. The city was very interested in making sure this embankment was protected, so we utilized some riprap. So the natural channel design approach can be used with more traditional civil engineering techniques as well to provide a multi-factor benefit for a project. But in this case, we thought it was a great compromise of traditional engineering approaches and biological uplift by incorporating a tow wood structure. Today, this is a picture standing on the road looking back upstream. The J-hook vein you saw in the last picture was here. We have another cross vein above it to help prevent stream bank erosion. And we see that that tow wood structure is already providing a living root mass there to protect the toe of the roadway embankment. So we were really pleased with this project. This project included a significant amount of native plantings as well to help us stabilize our floodplain areas and not have the channel continue to migrate over time in different directions. This is a picture from just last week of a project in central Kentucky in Lee County. This had previously been a large cattle grazing field. This house gives you a little bit of sense of scale of how large this creek is. This is about a 30-foot wide creek. Prior to restoration of this property, the channel had been along the valley wall basically and had been there for many years and was again eroded about 10 feet below the elevation of the floodplain. The stated goal of this project was only habitat improvement. It was a project where we primarily wanted to increase the habitat. So we created a much more highly meandering pattern. And as you can see in these pictures, we see some dark blue areas of deep pools and then some not as dark blue areas here that are the riffles in between our pools to create good variability of fish habitat for trout and lots of other native species. And in addition to the stream, we see wetland areas that were built as part of this project. So they can be really large scale projects that are exciting and fun to talk about. With that, I feel like I've rambled and covered a lot of topics. I would love to stop now and take questions. I ran a little longer than I told Lindsay I would, but I am available to stick around after the presentation today and take questions if anybody has any.
Thank you so much, Chuck. I just wanted to let everybody know we don't have any chat questions, so if you want to unmute or ask any questions, please feel free to do that right now. The Central Kentucky Backyard Stream Guide that Chuck mentioned is something in your virtual packet, and that's one of the things that we use and go through in our 101 class that was on, our workshop that was on last Tuesday and will be on this Thursday. So just an FYI on that, we'll go through that manual as well. It was a great presentation, very informative. If you all have questions or want to reach out to Chuck, I'm sure he would make himself available. Someone asked, is there a way to use wool for restoration?
Wool, that's interesting. As some type of erosion control?
I'm wondering, correct.
Yes. We can use a wide variety of things. What we use, and Rob mentioned this as well, a great temporary cover that is often used include oats. So lots of different types of oats, river oats and common oat, as well as annual rye. Winter wheat can be used. Rob had some reservations about that in the last webinar. But I haven't used wool personally, and it may, anything that can pop up quickly. If it's a perennial, it can be used again and again. If it's not, then it can be used more as a temporary cover. But anything that is a native herbaceous that provides dense coverage until your woody species can grow a little bit more, until the willows can grow over the course of 2 or 3 years, can be used, definitely.
It was fun to see all of your willow live stakes taking. We've done a couple projects with willows, and that it's always fun to do those live staking.
Oh, and you're talking about wool blankets. I'm thinking of different species called woolly this or that. Well, I'm not sure if they use wool for like erosion control fabric either. Right. I'm not sure if they use that for erosion control fabric or not. But that's something that you could look into.
Well, it's 4 o'clock, so you know, if everyone has to leave, that's totally fine. I can stick around a little bit if we have other questions, but I'll just remind everybody that we have another workshop this Thursday at 3. If you weren't able to come on Tuesday, please feel free to, last Tuesday, feel free to join us on Thursday. Thank you so much, Chuck, for your time and taking your time for this presentation. We'll stick around and see if anyone else has questions, but we can end here. Thank you.
Sure. I'll ask everybody, does anybody have a stream bank that they're worried about? Does anybody have an area where they're concerned that stream bank erosion is going to cause issues with their farm or with the structure on their farm or with their property or in town, anywhere? If you have specific questions, I'd love to talk to you more about that. And I'll pose that question to the group.
I'm trying really hard to hold my tongue because I have several projects in mind in my head and some of the communities we're working with, but I wanted to give people a chance.
Okay, I think I'm in. Can you hear me?
Yes.
Okay, I'll mute myself.
All right. Well, I'm sure that that's something that Chuck will be more than happy to touch base with anybody on. If you want to email him, his email was on that last slide. We will have recordings available at the end of the workshop series. So I am recording these and we'll have them on a YouTube playlist that's unlisted. So I'll be sending that out at the end of the workshop series for those of you looking for that. Thank you so much, everybody, and we'll see you on Thursday or next Tuesday. Thanks, Chuck.
Thank you all. Thanks, everybody.